So, good morning to all of you. As for the instructions, we have been forced to start 3-1 for all of you. So, 3-1 classes have been conducted actually day before yesterday onwards. For some technical reasons, my class was not started. Today it is the first class for Unix programming. And we shall have some brief history regarding to Unix. And already I have given some information to you that you people are expected to join in Google Classroom by using your email ID. I don't know how many people, 26 people have joined out there. I don't know what about remaining people. So in future, any kind of communication except the class link, any type of communication will be given to you through only that Google Classroom. And if anybody is sharing such kind of Google Classroom information to anybody, the people who are not joined to that, they will be identified and they will be punished. They will be penalized or punished. Okay, this is the point I'd like to mention here. And today's class will be, as far as the class is being concerned. So the class is being concerned. So let us take the syllabus. So the syllabus will be your syllabus will be taken something like this. Main objective of this particular course will be you are expected to have some kind of knowledge on multi-user operating system. Multi-user operating system in the sense, at the same time, many people will communicate with the computer, one server, and how the things are being happening will be known to you by this particular course. That is the first point. That is the first objective we are supposed to take into consideration. And the second objective is, technically speaking, how operating system will be and what are the different kinds of operating system primitives which are being there or which are being studied by you in operating system course will be coming to picture or will be coming to reality using this particular course, that is Unix programming. And finally, how to handle a particular system by taking the consideration of different kinds of commands in Unix or different kinds of system programs in Unix and different kinds of system calls and signals in Unix. All these things are supposed to be read by us or known by us by using this particular course. This is the basic point where exactly we are supposed to take into consideration. And after completion of this particular class, today's class, you maybe have some kind of clear information regarding to Unix and Linux, because we are supposed to have some kind of experiments or taking hands-on experience on Linux only, because Unix is not available for us. Unix is pretty much good operating system, but Unix operating system could not be available for us to load into our systems. So we maybe talk about Ubuntu operating system in nearer future, as and when basic commands are supposed to be discussed with you in after one or two classes. So, however, the completion, after completion of this particular class, what you are supposed to learn is what is the basic history of this Unix or Linux, who were introduced, who were right to this particular Unix or Linux, and what is GNU. So free open source software, how the free open source software has been emerged, and who is the responsible person to emerge such kind of a free open source software, and how Linux will be emerged, and how the things are being happening and coming to the real picture into the specific world. All these things are supposed to be learned by you after completion of this particular course. I mean, this particular hour. So let's get started regarding to this one. So, okay. However, Unix or Linux, you could take Linux also be same. Unix is a time-sharing operating system. Time-sharing operating system in the sense it is being, so time slice is being shared among several number of people, so that the people will be continuously have a communication with the system, I mean server, while doing their work with any compiler or any interpreter or any other kind of issues which are being available with us. And it is a time sharing kind of operating system, and this operating system more likely called as a kernel. It is not a direct operating system as like as Windows. It is having huge number of layers in between, so hardware and user. I'll let you discuss probably today if possible, otherwise tomorrow. However, it is a time sharing operating system which will be includes all different kinds of compilers, different kinds of interpreters, different kinds of editors, and different kinds of command languages and different kinds of utilities, something like this. In Microsoft operating system, you could not find any compiler, any interpreter, any editor. Of course, editors are there. Command languages are not available. Utilities, some of the utilities are available in Microsoft Windows operating system. Compilers in the sense you could not find C, you could not find C++ or Fortran or any other languages in Microsoft operating system. Whereas in Unix or Linux, yes, you can directly come up with C, C++, Java, Fortran, Python, and so on and so forth. Many kind of issues are there with us, and many kind of interpreters also be integrated with Unix operating system. However, this Unix operating system was so idea behind this particular thing is Ken Thompson. He is the person who is Ken Thompson, and he is actually he belongs to America, United States of America, but he was born in Kolkata in 1923, if I'm right. Ken Thompson is having a original idea regarding to Unix operating system, and his associates are Dennis Ritchie, who is the pioneer person in computer science. If he was not identified the C compiler, right now we could not take this much freedom to have all electronic goods into the picture. However, so Dennis Ritchie and Ruth Candy, he is Ruth Candy, and Doug McClory, he is Doug McClory. So these two persons are expired, and these two persons are right now still alive. These two are there. And in 1969, it has been took place in Bell Laboratories. Okay, in Bell Laboratories, so it has been taken into reality. And in 1972, one person in the sense is none other than Dennis Ritchie has designed and written C compiler. After writing the C compiler, complete C compiler, so Ken Thompson and Dennis Ritchie, these two people have rewrote the same Unix into C, Unix kernel into C again. So before invention of this C compiler, so this has been written in assembly level programming language, which is called as ASM, assembly level programming language, which is called as ASM, and which is somewhat a difficult kind of issue because it's directly communicated with hardware, and the people could not understand what actually this is. So to break through that particular confusion with the Unix operating system, so Ken Thompson and Dennis Ritchie has rewritten the kernel in C in 1973. So this is the emerging of Unix. And what about free open source software? What exactly this particular point or this particular word does means? He is Richard Stallman. He is Richard Matthew Stallman, who is the person who is the originator of free open source software. What actually happened for Richard Stallman? He is a computer scientist and a computer science professor in MIT. He was born in 1933, and he has taken his job in MIT by 1953. During that course of period, he is facing one particular problem with the management of MIT, that his friend who is working for physics department as a professor, and he was prepared some handouts or notes or material, and which was so given by him to other universities other than MIT. So himself he was distributed. So during those days, this distribution is a biggest crime, and his friend was prosecuted. So since he is a teacher, he is supposed to distribute that material to all students across the country, but he was not having such kind of freedom to distribute. So this prosecution was taken into account by taken to the what do you call into the mind of Richard Stallman, and he left the MIT, and he was came out, and he was started. So freedom of study and the freedom of use and the freedom of modify the software. So one movement was get started by him in 1953. So therefore, he was ensured that so freedom of so the software has been taken into consideration as free software, and he's also initiated one project. That project is called as a GNU. So GNU is there is no abbreviation for GNU. GNU itself is a small let me consider a small kind of a goat, which is a special kind of goat, which is available within North America. So he was taken that particular name of that particular goat, and he was introduced this GNU into the world, and which is founded and funded as a free open source software foundation. And also he was collected so many number of compilers, GCC in the sense G GNU C compiler collection, GCC. So what does it means? So thereby C compiler is there, Fortran is there, Python is there, R is there, and many other, Algal is there, many other, and everything has been taken into consideration. So during the collection of these compilers, is also so give some kind of postulates in the sense rules and regulations how so the free open source software will be distributed among many people. So if you are supposed to download anything, you must take care about all those free source software general public license here. This is called as GPU, general public license here, which was done by him in 1983 of September. Afterwards, so in 1991, he is the person, Linus Torvalds. He is the person. He is actually during that time he was a fourth year student of University of Helsinki, and he was started one particular project which is called so Minix, MINIX, Minix. So later it has been became as a Linux kernel. Okay, he's actually his fourth year project in 1991, and of course he wrote many number of utilities which are used to communicate with hardware directly, and later onwards it has been converted to Linux kernel. But actually he wrote this Linux kernel on 80386 processor. Of course later on, so he was also joined hands with GPU, general public license, and he was also give his all credentials to Richard Stallman's group, that is free open source software foundation. Therefore the Linux also becomes into picture as a free open source software. He is so Linus Torvalds, he is Richard Stallman. And however, he was developed during its development. So the name of Linux is Minix actually, and he wrote everything by using GNU C compiler, the C compiler which was originally developed by Dennis Ritchie. Okay, so using C compiler, he was developed everything, and this development has been so taken into consideration afterwards in 1994. So he was also joined hands with Richard Stallman. However, this is what about the brief introduction regarding to free open source software. In this way, the free open source software was emerged, and followed by how the Unix operating system, Unix or Linux operating system architecture will be. how this could be seen. Actually, any kind of system, whatever the system it might be, hardware is very, very important, and it is the innermost layer of any kind of computer system. In Unix operating system, it is the innermost layer, then followed by kernel, then followed by system call interface, then followed by then followed by assemblers, compilers, or linkers, however, whatever it may be, then shells. So here user will be available at this place. Okay, so user will be available at this place. So first hardware, kernel. Let me explain each and everything after coming slides. What is this okay, sir? I could not understand why people are giving okay, sir. Okay, however, so hardware, kernel, system call interface, assemblers, and all those things will be so innermost layers, whereas shell will be used to take the control of the user, and the user may be communicate with the Linux or Unix operating system at this place. We do have so three shells are available: C shell, bash shell, and corner shell, K shell. So three shells are available. Then followed by application softwares, we have to install them. Then followed by other application software, which are graphical user interfaces, something like that. Okay, however, hardware here, you need to understand one thing. Whatever this cell you are supposed to take into consideration. Yes, I'm speaking very, very loudly. And my mom and my sister, all those people are warning me why you are speaking something like that. Yeah. So hardware here, hardware will not be directly communicate with system call interface. There must be having some so kernel. Kernel is the interface between system calls and the hardware. And then how these things will be evaluated. Let us have a look here. And kernel. So the main components of Unix are first one is kernel, second one is the shell, third one is the file system, and the third one is file system. The fourth one is developer environment. These are four different types of components which are available with us. So kernel, it is a specific set of programs which are used to communicate with the hardware directly. And it is also used to control all kinds of resources which are being available with the computer system. So something like CD drive or microprocessor or memory or printer or memory cycles, however, whatever it may be, everything will be controlled by this kernel only. Okay, so kernel is a specific set of software which are used to communicate with the hardware directly. And so user could run their own programs using kernel, and you are unable to, there is no scope to you to directly communicate with the kernel. So you must use system calls. So the group of system calls will be called as operating system in terms of Unix or Linux. You have to use system calls to communicate with the kernel. You are not supposed to communicate kernel directly. And what exactly the kernel can be done here is, kernel is always trying to interpret the user information into system language, let me say mission codes, and therefore the mission codes will be submitted to hardware to work out. After getting some kind of execution by the hardware, it will receive mission codes from the hardware and interpret again into user-defined language and can be sent back to the system console. So this is the process which is being happening by the kernel. And it's also used to control all peripheral devices, as I just specified. All peripheral devices, something like monitor, input devices, keyboard, mouse, or joystick, whatever it may be. Everything will be gets controlled by the kernel only, and it will execute all kinds of commands which are issued by the user. So whatever the command you are supposed to issue at the shell will be taken care by kernel only, and it will be send separate signals to, input signals to hardware. Therefore, it could be work out something and come back come back from the hardware will be so resubmitted to the console. And what are the specific functions of a kernel here is, so kernel is always trying to make some kind of file system and its structure. How this could be gets happen as per the user's requirement. It could be take some kind of necessary actions on file system. And second one is device management, as and when your process is being run, and during that particular process running, you may be need many number of devices, and which device is required at this moment, after some time which device will be required, everything will be taken care by kernel. Of course, you maybe have some kind of idea about this device management in operating system when so process communication will be there in our operating system. During that what you call topic, you could have this device management with you. And any information which is being stored to the disk and which is being retrieved from the disk, everything will be done by this particular kernel only. So finally, what exactly it could be performs here in the sense, it is directly communicate with hardware. That is the final conclusion regarding to kernel. However, process management, how the processes are being managed among several number of users which have been connected to that particular operating system, and everything demands in the sense whether process will be gets activated or deactivated or killed. However, whatever the specifications you have learned from the Java, everything will be taken into care by the kernel only. And then finally, memory management. So how memory is being managed among the several number of users while they will be communicating with Unix or Linux server. And it is also maintained the swap space, cache spaces, heaps, stacks, and everything. Everything will be gets managed by the kernel only. So finally, what exactly I'd like to specify in terms of a kernel, in the sense it is a set of programs which are used to control complete system. Whatever the system which we do have with us, the complete system is managed by the kernel only. Okay. Then shell. Then shell is the command interpreter. Command interpreter in the sense, as and when you have to type any kind of command, obviously that command is being interpret into machine codes, and that machine codes information will be passed through to the kernel. Of course, kernel will be taking care about that machine codes into signals, and signals will be sent to hardware. Therefore, the execution will be gets succeeded. Of course, it is a fundamental tool, and any kind of process, whatever the process it may be, whatever the program it may be. Here in computer science, sometimes it may be called as a program, but in Unix or Linux, we must call it as a process, not program. However, everything will be gets executed by using a particular shell. We do have three different types of shells are there here. Those shells will be bound shell, C shell, and corner shell. Three different types of shells are available. So when situation demands, I will let you explain what is bound shell, what is C shell, and what is corner shell. So after the today or tomorrow's class onwards, we will work out on bound shell only. So we will take care about bound shell. As and when system call applications will be there, then we will work out with C shell. Corner shell could not be utilized by us. It is actually development environment. So it is not supposed to be taken care by us. We will take care about only these two. Either it is bound shell or it is a corner shell. Only these two will be taken into consideration for executing our operations, because we are the learners and we maybe apply some kind of command, some kind of system calls, which are being evaluated or executed by this Linux system or Unix system. And then followed by the file system. File system is a tree kind of system which is being available with Unix or Linux. It is the hierarchy of the directories or subdirectories or files which are being available. So it could be seen in such a way. This is called as the root. This is called as the root. So root might be having highest priority. And then you do have many directories. This is one directory, this is another directory, this is another directory, and so on and so forth. So here you could consider this is the system directory. And here all system calls which are available with with the Unix or Linux will be available at this place, and all other devices which are being connected, their routines or device drivers will be available with this DEV, and all compilers which are available with Unix or Linux will be available at bin, and all library functions which are available with Unix or Linux will be available with lib. And the users, if any users have been created, those users information will be available here, and any extra software which are used to specify, so that could be placed here in etc. And while doing any kind of problem, or while doing any kind of process execution, any temporary files will be required by you. Those temporary files will be gets executed, so gets created at the temporary directory. So these are by default directories which are available at level 1 after root. These are available. So this could be there with the Unix or Linux operating system. Thereby, user also have some kind of liberty to create themselves. Okay, so this is the file system which is being available, and then followed by developers environment will be seen in such a fashion. So normally this developer, the developer or programmer which may be able to communicate with operating system, Unix operating system, with system calls. Okay, you may be communicate with the system calls, and we do have many system calls which are related to files. A file can be gets created, a file can be gets opened, a file can be gets read, and data will be read from the file, data will be written onto the file. So file must be closed, and the file must be create some kind of links, and file whatever the links we have again created, they will be so unlinked, and if any white spaces or anything will be there, so that will be gets truncated. These are all different kinds of system calls which are available with the files which are available. I have given only this particular information, file information, and a new process will be gets created by using another system call that is called as fork. Fork is a system call which is used to create a child process. Whatever the process which is being executed right now, so through that particular process, if you want to create a new process, obviously you could take the assistance of fork. And you are also having some kind of signals. So signals in the sense, normally all signals will be called as interrupts. So normally, if any, while you are working with C programming or Java programming, if any infinite loop will be occurred by you, obviously maybe apply Control C. Control C in the sense break that infinite loop. That is, Control C is one kind of signal here. Okay, interrupt signal. This signal is called as 08H. This is called a 08H. As and when you are trying to execute any program, after completion of your program, let me say main will be get started at this place, and for example in C, so open brace, and you may be written as many number of statements, and you may be take this particular statement. After taking this particular statement, your program will be gets completed. Execution of your program will be gets completed. What exactly the statement will be, what kind of signal it is being passed to the hardware here in the sense 021H is going to be 21. 021H is going to be passed by C programming language, stating that yes, my program has been, execution of my program has been completely successfully completed. If 021H could not be sent by you, obviously any operating system will, either it is Microsoft or it is Unix or Linux, will think that your program has not been successfully completed. It was terminated by the user or terminated by any other circumstances. Okay, so this is being happening continuously in terms of doing some kind of this particular thing here, and then followed by how the things are being gets organized here. So the things are being organized. So normally Unix system is being divided into 3 modes or 3 levels. One is user level, and second one is kernel level, and third one is hardware level. So in user level, you are supposed to have, I'm talking this particular thing in terms of a developer point of view, not in terms of end user point of view. In terms of developer point of view, I'm talking developer point of view, you are always trying to execute system calls, and these system calls must be taken care. I mean, these system calls must be operated on either file systems or process controls. Afterwards, you maybe have in file systems, while using some kind of system calls, you maybe have some buffer. I mean, you maybe manage the memory in terms of buffer, and you maybe manage the devices in terms of file system or by using this particular buffer. And this particular devices or buffer will be taken care by the hardware controller. And finally, hardware controller will be taking care of the hardware. So here, three levels are available. So user level, kernel level, and hardware level. So normally, if you are supposed to give any kind of command, let me consider, so there is a specific command which are used for us, ls-l, which is used to provide some kind of data which is available in the present working directory. This command will be actually operated by you at user level. It will be taken by the system call and will operate, will decode it into machine codes and can be sent to file system. And file system must be always communicate with the device drivers of that particular device. Therefore, you could get the answer. Okay. In such a way, 008H is a specific call. I mean, it is a signal which could be always, wait for a while, control C, control break or control C. So as and when you have to apply control C, obviously 08, the signal number 08 will be passed to the kernel. So as and when 08 will be received by the kernel, obviously you could consider yes, break. User wants to break that particular operation. As and when you have to execute this particular statement in your main program, then it will be automatically sends 0 to 1 to the kernel, so that the program has been completely executed and successfully executed. That is what the information regarding to 21. Okay, control break also gets operated by you. Control break or control C or control shift break. You maybe have many signals, many number of signals are there. So each and every signal does have its own hexadecimal code. This is one of the specific codes. Okay. So in this way, so any system call will be taken. How the system calls are supposed to be gets activated. So as far as the things are being taken into consideration here, and this is the components of your total Unix or Linux system. Normally, in operating systems codes, in your operating system codes, you may be study about this particular thing, how the process control will be gets happen. You may be also study about the memory management. You may be also study about this file management system. And the system calls could not be there with you. Very small, very tiny information will be there in terms of system call. You maybe have some kind of data in first unit itself. So probably in our operating system course, probably today or tomorrow, he maybe get started. So he may be. It is operating system. It is not at a language. It is operating system. Somebody, I don't know his name, Spidey Tezu. He's asking a question to me that, sir, Unix is a subject. It's an operating system or language. It is not a language. It is an operating system. So difference between operating system and the language, computer language is always trying to communicate with the only the computer with the help of some kernel. But whereas operating system, in the sense, it is going to modify the features or modify the activities of all processes, memory or devices or file system or anything, whatever it may be. What actually the device will be gets worked out, will be managed or processed by the operating system here. Okay. So basic difference between operating system, Unix and other operating systems are, Unix is it is a particular kind of operating system which will be always used to communicate with number of users, continuously number of users. It is so clients, not exactly client server, peer-to-peer operating system. Directly you can communicate with the server without having any hesitation. Of course, prerequisites could be there. You must give some kind of authentication procedure before going to enter into the operating system. That must be there here. And other operating systems, in the sense, process controlling must be done separately in the sense you have to install some device drivers or something like that to control the process. And file management system, it has been done separately. And then many other issues are there. Too many issues are there. Situation demands, I will communicate with you continuously. I will illustrate you within 2 to 3 coming classes. I could not give you at this moment. Yeah. So this is what the class today, because we are running out of time. We just have only 1 minute of time. 1 minute of time with us. So so this is what the class today. Probably basic comments will be taken care by me by tomorrow. Okay. If any questions, you post me at any moment of time, I shall available for you.